Hi, I'm Dr. Robert Young, and I'm here at the pH Miracle Living Center at the Rancho del Sol in beautiful sunny California. And we are going to be talking about water today. Now, you probably are familiar with ionizing water machines, and there are many companies that are selling ionizers out there that create, through electricity, that create pH water, acid water or alkaline water. And these machines are quite expensive. They run around $2,000 up to $5,000. And so in thinking about that, I was thinking how much that excludes those who want to be drinking this water, yet they can't afford to purchase an electrical ionizer to create pure, clean, alkaline water. So I created the Watermark ionizer, which requires no electricity. And it works on a patented process of vortex pressurization. But prior to going into the vortex pressurization chamber, I filter the water, clean the water of all bacteria, of all sediment, of all silk. I take out bacteria, yeast, mold, and also chemicals that are commonly found in water, such as fluoride and chlorine. So we want to take out even heavy metals because we want a water that's going to be good for our bodies and not toxic for our bodies. And so in thinking about all the things that I would like to include in a perfect water, I envisioned this water machine that I call the Watermark. Let me introduce you to some of my props here. First, I'd like to show you my Octon ORP meter, which is an acronym that stands for Oxidative Reduction Potential. Now that's a lot of words, but what it means is we're going to measure the energy of the water, or its electron concentration. An analogy of that would be measuring the electrons of an alkaline battery. Batteries that are alkaline and fully charged run on electricity, and that electricity is the electron. So we're going to measure that with this meter. The other thing I'm going to measure is I'm going to measure the pH. The pH is a scientific scale that goes from 0 to 14, 7 being the midpoint. Our body fluids are slightly alkaline at 7.365. So the water we should be drinking should be at least 7.365. But because we're constantly producing acidic waste and we're losing our alkalinity, it's very important that not only do we drink clean, pure water, but it must be alkaline. An alkaline water that will help to neutralize the acids that are being produced through metabolism. So we're going to measure that and we'll get a number on the water. Now, just to start off with, I'd like to test water that you can purchase at the grocery stores. It's called Cure Water, and that's with a Q, not a C. And, you know, if I'm out on the road and I see this water, and I don't have any water with me, you know, this is a great alternative. One of its drawbacks is it is expensive. It's $2.50 a liter. So when you think about that, 4 liters is a gallon. That's $10 a gallon that you're going to be paying. And that's very, very expensive. But let's just test the pH and just see where we are. I've got my Octon pH meter, which measures the pH. pH goes at scientific scale from 0 to 14. Our body fluids are pH balanced at 7.365 to 7.4. I believe you should be drinking at least a pH water of 9.5 to help neutralize the acids of diet and metabolism. So let's just see how good this water is. And we want to see its electron concentration, because the body runs on electricity. It doesn't want to run on carbohydrates or sugar. It runs on electricity in the form of electrons. So these electrons can be measured. If we look at this, it's now registering. It's locking in at about negative 202 millivolts, if you can actually see that. And then I'll switch the mode over to pH. Well, it's dropped down a little bit to 197, 196. We're looking at a water that is about 9.56. So they're advertising a 9.5 plus water, and that's exactly what it is. It's 9.56. So that's an alkaline water that's electrically charged. It's a good water, but it's an expensive water. Let's go ahead from the Watermark, and if we look at the Watermark inside, so I'd like to show you the inside so you know what we're dealing with here. We can see that the water goes in first to a sediment filter, taking out silk and dirt and impurities. And then it goes into a nanofiltration system that takes out bacteria and yeast and molds down to less than 1 micron. And then it goes into a filtration system that actually remineralizes the water, puts the minerals back in, and these are specific alkaline minerals. And finally, the pre-carbon filter that takes out all the impurities. And then if you see this little chamber here, it goes in kind of like a funnel. The water goes in and it spins. If you watch your toilet when you flush it, it spins. It doesn't just go down, it spins, it vortexes. So it goes down from a larger opening to a smaller opening, which creates pressure. And when you're creating pressure, you create electricity. When you create electricity, you are then ionizing the water. So without electricity, because you don't have to plug this in, you can use it anywhere in the world, and because you don't need to worry about the voltage of the water. Where on electrical machines, you have to. So that is the inside of the watermark, which is a very sophisticated filtration system and a vortex pressurization ionization system that then creates a water that we can then look and see what type of pH we're getting. Now you can adjust the pH on this water. I've pre-adjusted it to around a 10, 10.5, but you can adjust it down. Right here we're testing at about 11.6. So if you look at that, 11.6 pH, okay, and we turn it over, that's the pH. The ORP is up to negative close to 300 millivolts. So we have an electrically active water. And the beauty of this is for a liter, rather than paying $2.50 a liter, you're paying about 1 to 2 cents a liter. Because you can make this at your home, and whatever your water bill, you figure that out. But when we're thinking about, well, an average person weighing, let's say, 70 kilos or 154 pounds should be drinking at least 3 to 4 liters a day to keep hydrated. Well, the quality of the water is very important because you want to be drinking the best clean alkaline water. Well, if you're drinking 4 liters of water, of bottled water, you're spending $10 a day on water, where in reality you'd be paying, if you're drinking the water you make out of the watermark, about 12 cents. Okay? Maybe less than 10 cents a gallon. So that is the quantitative information. Okay, so we're going to look at the water qualitatively and actually use some reagent drops, and it changes colors. If we look at the color chart here, you'll notice that the more acidic waters will be at the lowest end, red, and then it goes to orange, and then to yellow, and then to green. And then the next colors, which are the alkaline colors, which are green, blue, purple, and white. Okay, so we're going to look at the water qualitatively and actually use some reagent drops on 3 waters here. The first one's going to be Aquafina. The next one's going to be Cure, not with a C but a Q. And then we're going to use our watermark water. And if the water turns a yellow color, then of course we know we're dealing with an acid water. And this water has a positive ORP. And we'll go ahead and add some reagent here and see what we've got here. And the color that we're looking at here, I don't know if you can see that or not, is a yellow or orange color. You can see that? Okay. And an alkaline water will turn blue or will turn purple. So I know what this costs because I buy it when I go to the store if I need water. Runs $2.50 a liter. This one's probably, about $1 or so. I'm not exactly sure because I don't. This is tap water that's been purified. This is an alkaline water. It's gone through a system, and then we've got our watermark water, which has been vortexed and pressurized alkalized to a high electron concentration and a high pH. So let's take some of our reagent here, and we'll take some more here And we'll see what kind of color we get. Oh, I love it. It's a beautiful purple color. We can see this is a lighter, well, it's about the same color. This is running about a pH of 9.5. We've got a pH of around 6.7 to 6.8. And then we have a pH here of around 10.5 to 11. In our little kit, we do have, these little charts here, so you can actually see it's 6.8, the color, and then of course the purple colors. This is a light purple going to a very dark purple, which is up in the 9s and 10s. So qualitatively, we can now see the different types of water when the reagent interacts with the protons and electrons, giving the color. Also, we can test its electrical conductivity. Electrical conductivity, our blood or our body fluids are salted with sodium. And that acts as a matrix to transport electrons to all the different cells, because our body runs on electricity, kind of like a cell phone. Cell phones, you have to keep recharging. We have to keep recharging our bodies. That's why we eat food. We eat food for its electrical potential. And you lose that electrical potential when water or food is processed. So let's see if this lights up here. We can see our light meter here. And we're getting no electrical conductivity. So this is not an electron-rich water. It's not a mineral-rich water. We've got the cure water, same thing. And then we have the watermark, and there you have it. So the watermark will light up the light because it's pure, it's clean, it's saturated with hydroxyl ions or electrons, and it has the minerals to conduct electricity. This is the perfect water.